Hi, hello everyone. To the viewer of AIS Week 2026. And this is a roundtable session titled Computational Design Beyond Architecture. Uh, so this session is about re-examining the boundary of computational design. And I invited three panelists from the different field of architecture. Then let me introduce each panelist. First, Volkan Alkanoglu. He has an architecture background, graduating from UCL Bartlett, and he also taught at many institutions, including SciArc and Georgia Tech and Harvard GSD. And I think I started teaching at SciArc right after you left or something. So then after after he taught in architecture school, he had led the computational design division at Nike, and then now he's at HOKA. And then he also has a computational design practice at his firm, V/A Design. I'm not sure I should read it VA Design or not, but he's also engaging in many computational design works as well. Thank you for joining. And then second presenter will be Brian Harms. He went to SciArc as well, and he was taking one of my computational design seminar. And then he was at the postgraduate program called Emerging System and Technology and Media, which was called MTech. And then, well, ESTM, sorry, MTech is different school. And then so at the school he engaged in the active design and digital fabrication, especially with robot arms. And after graduation, he worked at the Samsung Research America think tank as a senior staff research engineer, leading R&D across robotics and AR, VR, and then spatial interaction and then experimental products. After this experience, he founded his own creative technology company called Ritual.Industries. Independent practice exploring intersection of hardware, software, and automated making. And some of the work had reaching over 15 million views online. And then third panelist, Mary Franck. She also had graduated from SciArc, but prior to that, she had a background of education in art, fine art as well. And then after graduating SciArc, she has engaged in experience design and integrating her skills in architecture, art, and technology. And then she worked on a commercial project for world-leading brands like Google, IBM, Cartier, and MGM. And currently, she's an experiential creative director at a creative agency, Hyperquake. Thank you for joining. Okay, so let me start with my introductory presentation. So yeah, as I mentioned, we're gonna do this panel discussion with those three panelists. And then first of all, I forgot to introduce myself. My name is Satoru Sugihara, the computational designer at ATLV. And then, so the key point of today's session is, in general, when we talk about computational design, either for general people, for general architecture practitioners, we think about, mostly think about a grasshopper somehow, and then think about computational design is about the design ideation with this kind of platform, and then realizing complex geometry, and then also about like optimization of those geometry suitable for construction. But not necessarily the case when we see the whole range of work. And so today's point is re-examining the boundary computational design with those panelists. Then to look at the kind of scope in general of computational design, we look back at the history of computational design. And on the book by Neil Rich and the Filipino, actually he even started from the history of computer itself. But anyway, so there's several, actually 4 different lines of history coming into computer design, in my view. And the one is a computer-aided design research, so CAD research. And then actually the work I'm showing, 3 of them all happen at MIT. But So early work in even 60s to 70s, there is a certain groundbreaking research work in CAD area. And then even like the left side is developing the interface itself. And then two others are kind of generative design system, including shape grammar. And then another line of history of computing design is generative design. I mean, generative design is one area inside computing design today, in my view. But that has origin in generative art, or in 60s, it was called computer art as well. And then, so the middle part is the computer artwork by the Frederick Nake, but the even like in pure fine art world, like so Louis started the drawing by just writing down the rules, so not using any computer itself, but just a rule, a drawer follow just the rules to complete artwork. So that's another line. Then yet another line, the algorithm design. I see John Maeda is one of the kind of origin of these works. And then actually, John Maeda graduated MIT, and he had led MIT research group called Aesthetics and Computation group. And then but before he started MIT Media Lab, he was in Tokyo and then going to art school. And then he was at the research institute in Tokyo, and he studied this graphic design generated by computer programming. And actually, I used to work at the research institute after he left. And then, but so this line of work influenced the architecture and then kind of serialized as algorithmic architecture by Kostas Tezidis. And then the fourth one is the kind of history of kind of leads to this grasshopper-like visual programming. And so there's a history of visual programming, actually, which is much longer, but one of popular one was like in 80s, Max MSP was a music and sound generation visual programming platform. So there's those kind of line as well. And a quick view of the whole computing design from the 90s to now. So actually, I see the digital architecture start of that by Greg Green and some other colleagues, especially at the Columbia University. But the deconstructivism is a kind of predecessor, directly influenced them. But so from the education at the Columbia University, the paperless studio, many students came out and they became like a second generation digital architecture architect, and including Hernan. And so that you can see that like a resolution of like a curvilinear form is actually getting higher. And then that trend of a higher resolution is kind of continues to digital fabrication work and also scripting architecture, which I just naming that way, which means that architects who actively computer program to for the design work. And then so this resolution is much getting higher and higher from towards 2010. But from 2010, I see the diversification of like a topic, what to do with those technology. And then one area was robotics, and another area is the design work influenced by speculative design, which was originating from RCA London. But for more talk about the narrative or future narrative using technology. And then another area of the design work is discrete architecture, which is kind of formed by the graduate of AA school DRA, and then focusing on like construction using discrete components, although still using heavily the computational design technology. And then there's another line of kind of design. Is the AR and VR architecture, although which is not as a group, but there's a group, many architects trying to use this technology to create a new design work for AR construction or realizing the project inside VR. And then it's a bit arguable that the object-oriented ontology architecture could be part of computer design or not, but this is a work influenced by the philosophy of object-oriented ontology by Greer Marman. And then the final one or current one is kind of some AI, but that is actually might be we are in a different era right now or getting into different era. But that's I mean that's just a huge impact of AI and it kind of changing. So the weird thing is that the 2010 to 2020 we see the diversification, but somehow the AI is kind of with this impact converging into kind of more uniting the interest toward AI itself. But anyway, so that's kind of quick history. And then, so by seeing those origin and the history, we see, I mean, computational design itself is already kind of diversified. It's not that singular area. But with that in our mind, we want to see today's participant work, and then we want to discuss what's the boundary of computational design and what's the essence of computational design. Right. So that's my introductory presentation. And then, okay. So now, so I like to invite Volkan to present his work. Not sure how much you can show your shoe design work or your computer design practice, but yeah, please, yeah, start presentation.
Yeah, thank you, Satoru. Also, thank you for the introduction. I'm going to go ahead and share my screen.
Yes.
And you let me know if you can see it.
Yeah, I see that.
Okay, just go on full screen. Can you see my preview, or can you see the
preview is shown?
Okay, let me just swap this real quick. Is this better?
Yeah, now full screen.
Okay, excellent. Yeah, so I titled this quick talk In Pursuit of Novel Systems, because I think that maybe in the current age of digital tools, it's really about a combination of many factors. So it's really about how things align and come together. So systems for me might be, one of those avenues that we can look at. Especially when you break it down, I'm very much interested in formation, technology, and material. I feel like those are the four pillars that I kind of base my work on, and use them kind of to navigate a little bit. All the projects, I'm going to show a couple of projects. The first one is a pavilion, as with many people, they have the chance to do small pavilions to kind of test some of these ideas when it comes to computational design. So this was a pavilion that's located in Denver, just northwest of Denver. It's on this like park landscape that's like a water basin. So when there's snow in the mountains and water comes into the urban landscape, so this is kind of to hold the water. And the client asked for like some sort of feature that celebrates the park, maybe gives an opportunity for people to come together informally, formally, and so on, and also just become a bit of an iconic landscape element within the park. So this is the kind of a project where we can test many ideas. And one idea was when I go back to form information, is the form itself of the pavilion, which are these shell structures. There's three of them. Actually, the pavilion is symmetrical in its profile and in its kind of shape, but the tessellation of the surfaces is not symmetrical. So we use totally different logic there to kind of give it this counterbalance in a way. And the same goes for the coloration of the piece. It's not symmetrical. It has a different logic that we applied. The other thing to mention is obviously when we deal with fabrication and how we build things, we want to break it down always to a level where we can handle those pieces, where we can fabricate those pieces with materials and technology that we have access to. So the idea was here to kind of break the geometry into these developable surfaces that we can just lay out flat and cut from 4x10 or 4x8 sheets of material. Once they are cut, then they can be assembled, they can be painted, they can be assembled back into the original kind of anticipated form and shape. And in this case, also for this to work structurally, we actually introduced a system where we have an internal shell and an external shell, and it kind of combines creating this double structure. We worked with AKT2 Engineering in London on this project. And the other thing that you can do introducing into this kind of very thin kind of surface of the pavilion is you can introduce obviously color, texture through these kind of mechanical fasteners. But also, if you look closely, there's these moments where towards the bottom of the pavilion, there's no gaps between the elements. And the higher you go up, the gaps open up. So what happens is, because of the tessellation of the surface, we have more space, more area. But this also allows us to introduce these kind of openings that create this kind of very ambiguous openings and shadows that occur. And these are things that you can't really simulate when you necessarily design this piece or when you conceive it initially. And then yeah, we built this locally. There's an amazing fabricator named Demiurge Design in Denver, who we did many projects with at this point. So I just want to show a little bit behind the scenes what it takes to kind of bring this piece to life. Obviously, there's a lot of cutting, there's a lot of metal work involved. You know, when we have these tools available like Grasshopper, etc., we are able to really have control of all the quantities. We can mark every piece. We know exactly where locations are. So those are really, you know, the kind of tools that we use to kind of help us not just fabricate, but also guide this project assembly. When it comes to the assembly part, there's hundreds and hundreds of components that somewhat belong together. You just have to kind of solve the puzzle. And again, those tools help us to understand how we can start to integrate the procedure and the way to connect one piece to another. Yeah, so just a few more images of the pavilion and basically how it came about. Another project I want to show is located in Durham, North Carolina. Here we wanted to try a totally different way of approaching it. So we teamed up with a company called Branch Technology in Tennessee, and you know they are specializing in 3D printing, particularly in 3D printing of large scale structures. They have IP on something what they call a matrix prints, which means that you can actually use a robotic arm and print an ABS/carbon mixture. It hardens very fast. And what it allows you to do is basically you can print in space. So that is interesting. It's not just depositing layer after layer, which we're used to in many 3D printing applications, but this is a bit of a different technique. And what it does, it creates volume without much mass, right? So you have much more lightweight pieces, while you also don't compromise on the structural integrity of the form itself. So yeah, we had the chance to design this piece in front of a library in Durham. And the ask was to also work with the community to understand really what's the desire of the community and what they're looking for. So we did a survey where we asked, I think there was 1,000 people that participated in the survey. We asked them about their favorite author, their favorite books, and so on. So we really want to understand a bit more of the community and their interests. And one of the books that stand out was a book called Harold and the Purple Crayon, which is about, it's a kid's book, it's a children's book. And it's about a young boy that just imagines the world with a crayon in his hand and starts drawing everything that comes to his mind. So he starts drawing streets and trees and everything, and it comes to life. So in a way, if you look at this piece, it's very much in line of that kind of crayon, the purple crayon kind of symbolism. And it's a gesture of that crayon in a way. But again, to build this, you need to kind of think about, again, how do you use the technology and the new methods of make that we have available, and actually think about it from end to end. And the piece itself is trying to optimize within the budget, so you can actually calculate how much material and volume you can use with the budget that you have available. And that was one of these interesting objectives to us that we can use to really play how much we can stretch the design, connect some of these pieces while also maintaining a structural capacity for this thing actually to function. So here, when I talked about the matrix earlier, here's just a close-up what that looks like. We really think about it's like having toothpaste coming out of a tube. at least when you zoom in. When you zoom out, it's a more homogeneous aesthetic. And the interesting part is that we're using this very high-tech way to produce it, to fabricate it. But the way it's connected is very simple. We're just using off-the-shelf zip ties to put these things together and connect basically them one by one. You see here images where the 3D print that wasn't painted yet, and then the painted version where we did a quick mock-up, and you see some of the zip ties sticking out before they get cut and painted as well. Yeah, so this was an interesting project for us because it was the first time we used 3D printing on this scale. Typically, we have used 3D printing more for like prototyping or little models. And for us, this was an interesting experience to actually use it on a much larger scale on a permanent installation that I think was installed in 2022. So it's been 4 years that this is already standing there in Durham. And since we also had the chance to do a few more projects with Branch and also, deliver projects both in Denver and in Cambridge, close to Boston as well. And then, yeah, I think we're close to time, but maybe just the last project. This is, again, a totally different paradigm of how we go about some of the projects. This is actually a bridge that we designed in Fort Worth in Texas. This is, obviously always interesting for an architect to design a piece of infrastructure and a bridge. We tend to design chairs very often, but a bridge, I think, is also something that's quite intriguing, simply because we kind of stretch a little bit the boundaries of what we usually are exposed to. In this opportunity, we had the chance to design not just a piece of infrastructure to connect basically two neighborhoods that were split apart by this artificial creek that was introduced a long time ago, several decades ago. So this neighborhood never had the chance really to meet each other, except they were driving for 1 mile each direction to kind of get to see their neighbors. So the idea here was to kind of, stitch the neighborhood together and introduce, an infrastructure that is not just a connector, but at the same time maybe also an element that can start to trigger a bit of a community measure where it's more of a sense of place. And part of that was for us to not just design the bridge, but also design some of these elements like these benches that come out of the surfaces, where you can then, maybe rest, take a bit of time to kind of enjoy the landscape, which is a beautiful creek in that area, and use this really as an urban device that people can participate in as well. So the bridge is made of really 2 elements. There's a steel structure inside that I'll talk about in a second, and then you have this exterior cladding, which is very much in line with the pavilion's tessellated like. So the way we tessellate the pavilion with these aluminum elements is here. We replicated the same technique with these wooden elements. So we built this piece in Indianapolis with an amazing partner called Ignition Arts and Lucas Brown Studios. So we built these 60-foot long steel elements, and then slowly started to kind of introduce these sections to it. You see here, one of the fabrication team members. So you get the size of the scale of this piece. It was quite large once you're sitting right next to it. And then we're building it basically like a boat, right? So in a boat you have a hull, and then you introduce these sections. And sometimes even before we started to put the wood on, it was actually quite intriguing as a structure itself. And then we're kind of joking that maybe we should have just left it as is without the wood panelings. But maybe if we have the chance again, we might just think about it in that realm. But then with the wood panels, this is actually a type of timber called Spanish cedar. It's a very hard material that you can that's still malleable, so you can still bend it. We actually had to put it into a steam kind of space where it gets a bit more malleable before we start to apply it to the structure. We also, when some of the curvature was very complex, we had to actually flip mill the pieces to allow it to actually bend better into place. And then we start basically then step by step building this up. And this was also built during COVID, so there were many challenges when it comes to access to material, labor. In general, those times were different kind of put the projects together. There was a shortage of material, shortage or longer wait times for materials. But ultimately, we had the chance really to kind of put this together. And the idea was always to build it off-site and then ship it to Texas. And then we used some of this AR, VR technology to kind of also test how this would look like actually when the piece would be on a trailer. So we kind of used AR to put this onto the trailer and see if it actually works. And then ultimately, we also had to, of course, consider the size of this bridge when we designed it, etc., but also the width because it had to come in and out this gate of their fabrication shop as well. And then, yeah, we delivered it to the site. And then when it arrived, the task was also to make sure it doesn't take too long to install. So we shouldn't block the streets for too long for this neighborhood. So part of that process was also integrating it into design as well. So how do we create a piece that we can introduce quickly to the site and not just build a scaffolding first and spend a lot of time on the site and close the roads, etc. So we introduced this what we call plug and play system, where we really bring this thing to the site, have a crane, plug it into place into the existing foundation that we have poured previous, and then pack everything up and leave. And this whole thing really just took a couple of hours, which was the initial plan. And all the planning worked out. We actually managed to get this thing there just as anticipated, lifted it into place. Had already foundation poured with, again, some amazing fabricators and contractors on site. And here, maybe just a few seconds of this video where you can see how quickly you can install even this kind of massive structure. I mean, this is many, many tons of weight. It just looks like so easy to lift. There's two gentlemen with these ropes guiding it into place. And then Lucas, who is one of the main people to bring it to life, is somewhere in the back, and he's just telling them exactly where to position it because we had these like existing foundation systems where this would basically then land and be fixed as well. Yeah, so this kind of concludes just the quick kind of projects I wanted to share with you. Thank you.
Right. Thank you very much for the amazing work. Okay, then Brian, go ahead. Yeah, presentation.
Thanks, Satoru. Let me share my screen here. All right. Can you see my screen?
Yes.
And hear me okay? Cool.
Yeah.
So my name is Brian Harms, and yeah, the topic of computational design and where the boundary is around it, I think that's a really interesting one, because my mind kind of comes to like the optimization of geometry, and that's actually like something I've never really done myself. So even though I've been called a computational designer for most of my career, it my role in that has felt a little bit strange. So I'm going to show a few projects from my website, and you can find all of these projects on brianharms.design. But to kind of like explain the beginning of my story, like this is the first project I did at Cal Poly in architecture school. It was every architecture student has a Voronoi, algorithm rite of passage where they make something with this algorithm. But the reason that this kind of like is important to me is because it started kind of a journey of being obsessed with things that can only be that can't really be produced by hand. Like, okay, I guess you could argue that this is something that is producible by hand, but not like realistically. And so this kind of obsession with like conceiving of systems, like Volkan said, that are only achievable through kind of a relationship with technology is kind of what my obsession is. And so this is like it's like a 3-minute kind of teaser trailer of all of the different projects that I've worked on through undergrad and grad school. That's when I think about it now in the context of this conversation, I think is like it went from kind of computation to design form to using computation to design experiences that create novel interactions with technology. a lot of the time that was in service of making. So, the previous video was like rapid liquid printing, which was like the first kind of conception of that in 2012. A lot of this transferred over to Samsung, where we were doing a lot of like interaction design and enabling experiences where ideally the technology would be kind of invisible, but it was also like at the core of the experience. And so after this video, I'll go into a little bit more detail about a few different projects that I liked and were kind of like representative of my time before and during and after Samsung. But yeah, like at the core of all of this, it's like my obsession is with like how you relate to new technologies and what that experience feels like, and yeah, it's how you can kind of like express some of the kind of artistic visions in your mind through technology and then share them with other people. So the my favorite project from SciArc was suspended depositions. So this is a project that looked at creating a new way of 3D printing. So this is injecting UV curable resin inside of, it's actually hair gel. And the thing that I loved about this was like designing the entire system, like coming up with the idea, designing the end arm tool from scratch, like programming the Grasshopper file to coordinate all of these things, in addition to, designing my own inverse kinematic solver to be able to control the robot. And so, yeah, where my brain kind of like really feels in states of flow and feels kind of alive is like in the putting together of all of these different things that all have their own unique challenges and synthesizing it into something that hasn't quite existed before. And if this does look familiar, it's because MIT and Disney kind of like ripped it off a few years later, but that's fine. When I graduated, I went to Samsung. I worked on a group called the Think Tank team, and we did a lot of projects that were kind of secret and never became public because that's kind of the nature of R&D. And other ones did kind of become products and productized. This was an example of an interaction kind of focused technology where I also got to use some of my architecture degree. And it was basically like a system to make anything or in your environment like gesturally interactive, and it was done by using depth sensing to create these like interactive volumes nearby objects that you could then touch to trigger specific content on a display in this case. And this demonstration that is happening in the video is when he moves over to the tablet. Let's see, I'll skip it. Yeah, okay, this shows how easy it is to kind of set up, like this thing that he's touching right now is not currently interactive, but we have this app that we developed to be able to draw these interactive volumes in space and then connect them to the content that you wanted. And now when you interact with that space, the content is triggered. So we pivoted that into a product that was looking at retail environments, because stores where products are relatively in the same spot for long periods of time and people are interacting with them is like a great use case for this. So we developed this for Samsung and piloted it in a bunch of stores. And so people would pick up products and then they would get relevant information on a screen, whether it's like an advertisement or pricing information or color information, whatever. And then the other interesting thing is the retailers would get metrics based on how often people were interacting with different products. So that was interesting. The big project that I worked on at Samsung was called Bot Chef, and it was our future product concept for what collaborative robotics might look like in the home in the future. This was back in like 2018, 19, 20. So this is kind of pre AI, but we were thinking ahead to like when these systems will be in our homes and powered by AI. What might those interactions be like? So we developed these. This was actually a team of like 10, and I managed the team, and we designed all of these demonstrations for these robots to interact with different things in the kitchen, different like utensils and things that you need to make a meal. This is actually an earlier version. This is the later version. So yeah, we also added in the final version, we added this rail system so that the robot could move back and forth and kind of cover more area underneath your cabinet. And it has a couple of like cool party tricks that it'll show off in a sec. But yeah, it's used like a vision pipeline that used depth sensing to understand kind of roughly where things are in the environment and knows how to avoid things in path plan to be able to not run into things. And so this is a really interesting project to think about, like, okay, well, not only like how do we make the robot capable of doing these things, but then like how do you interact with the robot as a human being? So we'd explored a lot of voice interactions and also like touch interactions where we made the entire shell of the robot capacitive or sensitive to touch, so that you could basically, like if you bumped into it, it would pause and stop, and if you double tapped it anywhere on its skin, it would continue. We also embedded like a camera in its wrist so that it could, as it's like navigating different spaces, it can recognize objects and grab them. So this is like, this is still, even today, this would still be considered a future product concept. I don't think that these are, even though, AI is making huge leaps in the robotics world, I think it's going to be still quite a while, but it was fun to be able to be given the opportunity to prototype what we think these experiences kind of should feel like. And we helped kind of Samsung invest more heavily into their robotics research as a result of this project. And then after leaving Samsung, I started my own kind of independent design thing called Ritual.Industries, and you can see all that work on Instagram. And I started off by doing things kind of at the intersection of like AI and 3D printing, fabrication, automation. So this is a project that looked at using a custom GPT to describe an object, and it would generate Python code to make the object that you described, and it would automatically it would take that code, it would put it online. Grasshopper would pull the file where it existed for the Python code and pull it down and run it. And then you would interact with the AI to change the geometry. And when you were ready to print it, you would just tell it that you wanted it to be printed. And it used Python to automate all of the interactions with Bamboo Studio to print the object that you wanted. So it was things like this that create these experiences that feel kind of magical and futuristic. When people go like, oh, it's something out of like Iron Man, or so, oh, it's something out of Star Trek. Like those are the things that really like excite me, and I like to try to see if I can find the path of least resistance between those two different things, like voice and printing, and trying to connect the dots between those two things to kind of invent the system where that works. And nowadays, this is like AI's gotten so good, you can do this like pretty easily and way better than I was doing it. But this is a couple of years ago. Things have actually changed so much that now I'm working on a version of this where I'm automatically printing monolithic objects that are also their own shipping container with the UPS logo or label printed on the box itself. That's been a fun project. And then the last thing I'll show is this. This is a really fun kind of exploration that I did that was looking at kind of trying to. There's a few different angles to this. One, it was like a fun, just industrial design project, but it started from this idea of wanting to make enjoying music a tangible experience again, because kind of more intentional. So this is a 3D printed cassette that has an NFC tag in it. And then there's an app I developed for the phone to, when it reads the NFC tag on the back of the phone, which happens when you close the cassette backing, it would launch this app and then retrieve the playlist data from the NFC tag and visualize the playback digitally as kind of this retro cassette player. And you can store additional data on the NFC tag as well, like if there's a music video or the color of the tape. And so the kind of cool thing about this was like, it was a system that involved industrial design, it involved software development for the app, it involved like hardware and integration of the cassette kind of as an object. Um, and all of it was in service of the kind of experience that you would have with this, which is like your phone is in this sort of plastic prison where you're not, interacting with it or being distracted by it. And, you have this kind of intentional way of saying that this is the playlist that I want to listen to right now, as opposed to having, infinite access to everything on Spotify. So those are the projects I wanted to share today. Thanks for the opportunity. I don't know if there's a through line through any of that makes sense or is related to, in a core way, to computational design, but I do kind of think that computational design is an element of all of these projects, and maybe my view of it is it's kind of the zoomed out view of the entire system, and using technology to create the entire system. So thank you.
Right. Thank you very much, Brian. Okay, Mary, can you start your presentation?
Hello, I'm Mary Franck, and I'm going to speak today about computational experiences. Again, thank you, Satoru. This is a great opportunity, great to connect with these other designers. I'm an experiential creative director. I've worked mostly commercially, some time in academia, but I work across a number of different experiential formats, including events and exhibits, live performances and experiences for stage, pop-up retail experiences for brands, and data-driven interactive projects. But one of the things that ties all of these together was that these are experiences that take place in spaces that bring people together to experience a time and a place together, including digital placemaking. And I think what excites me about computational design is not only the unique forms that we can generate, the unique complexity that we can generate through computation, but the dynamism that we can create, the time-based evolution or growth of different systems. I enjoyed your survey of computational design history, Satoru. I was looking into some of that as well. And it's interesting, so much of the computational design tools that are popular within architecture and CAD, AutoCAD, etc., have grown at the same time as a lot of computational design tools in entertainment. And a lot of the tools that I use are more from the entertainment side. So systems like Houdini or Touch Designer that use the same kind of computational simulation for visual effects. I work on interdisciplinary teams as a creative director. The projects I'm going to share with you are created by teams of people that I've worked with. I'm really proud to share this work. The three strategies that I typically employ for making these dynamic spaces, for making computational design experiences, are algorithmic animations, data visualizations, and interactive media. And so I'll take you through a case study as an example of each of these strategies. The first example is a project called The Prisms, and this is for a building in Edmonton, Alberta. We created a series of these large-scale video chandeliers to go throughout this space, and we made site-specific digital video to express the site and changing weather, and as well as different color palettes to shift the space over time and over the course of the day. So we made a series of different three-dimensional environmental scenes that reflected Edmonton, the world outside, different trees, actually based on the aspen trees that are growing outside that change color with the seasons: green leaves in the summer, orange leaves in the fall, bare branches in the winter. So it's this digital video piece that evolves over the entire year. Here's some samples of snow falling on the leaves, snow collecting as a simulation inside the video box, as well as some of the abstract digital content that we would use to transition between these different scenes. this was, it's a really unique canvas. As you can see, it's a 5-sided box. And so it's challenging to make content that wraps seamlessly around this in a way that creates a sense of depth without, um, kind of breaking from different perspectives. Typically, when people make content with depth for this kind of service, they use a technique called forced perspective, and you've probably seen this on anamorphic video displays, where you take a scene and you're projecting the three-dimensional scene onto the surface, and it allows for this illusion, but it only works from one perspective. But of course, we're designing for this space that people are transiting. There's different entrances and exits. So we didn't want to create a hero point of view. We wanted to actually have the experience be, as beautiful from every different position. And so we came up with a few different strategies. My technical director, Adam Carlucci, developed a lot of this. And we created these, orthographic camera rigs to allow for these simulation patterns for example, the snow accumulating inside the box, as well as doing kind of sophisticated warping to allow images with more depth to wrap around the surface. And it was interesting designing content for this because these illusions worked well if we created the sense of shallow depth, like you were looking into the box, but not that deeply. So the sense of um, mysteriousness or having things that were really close to the surface worked quite well. This was one of my favorite scenes. We simulated the box being fractured and then having light play through those fractures and reflections. So I think that it's an interesting computational design challenge to design video content for these much longer spans of time than you typically design video content for. So this is all computationally driven, and that these seasonal changes are driven over time, so that we're allowing this thing to unfold over these longer time spans. And then the pieces like this are actually computationally recolored so that they're able to, you know, live in the space and have a different color expression, maybe based on time of day or a special event. The next project I'd like to take you through is one for a workplace. This was for Spectrum, which is a telecom, and they have a headquarters in Stamford, Connecticut, and we introduced these architectural column video displays, and we wanted to express the culture of the company and the culture of the different cities that they serve, but also to tell the story of the network itself, the technology that underpowers all of their services. We also wanted this to be dynamic, to change over the day, and to bring data actually from that network into the building. So we made a series of data visualizations working with their analytics team. We analyzed the data use of 12 different cities, and as well as the data use across the network, across different kinds of data. How much of the network was being used for video, how much was being used for gaming, and so we made a number of different scenes, but two scenes that I'll take a special focus on are these data visualization scenes. I think the ability to not just tell a story, but to really illustrate like a company's values or their activity through like concrete data is a powerful opportunity, and it allows for just interesting observation. This is a map of Manhattan, and you can see the data uses is being, higher squares reflect higher data use, lower squares reflect less data use. And so you can see Central Park is not using a lot of data at this particular moment, but Columbia over here in Morningside certainly is. Likewise, the financial district is using a lot more data. And so over the course of the day, this visualization, it rises and falls as people use more data in certain areas and work areas, then they return home and use more data, they turn on their video streaming, etc. And so it was a really interesting lens on the activity of the cities that they serve. And it was great to work with these larger displays, like not only because of the monumental size, but because of the resolution. We're a little bit habituated to working on small screens and, usually 1920 by 1080 resolution. You can put so much more information at this scale, and it was really amazing to be able to convey all of this at once while still creating focused moments of attention. The other visualization that we did is a visualization of data use over time across the network by type. And this is hooked up to their network. It's updated and refreshed on a regular basis. And so, over the years, that I think different trends might be exhibited through this. We surveyed several different categories of data like messaging, gaming, email. Of course, video takes up the largest, video streaming, like video calls like we're doing now, take up the most data right now on the internet. But I think we'll see other things like gaming and entertainment take up more in the future. So I think, yeah, data offers a lot to the built environment, but I also love having the opportunity to create direct interactivity so that people who are in a place can have this experience of directly affecting it and directly changing their experience or their environment, having their action amplified for others. This is an art piece created in Bethesda, Maryland. It's for a multi-use building, and it's a volumetric light sculpture called Murmurations. It's inspired by the flight of birds. And it's a 60-foot CNC bent steel strands that kind of undulate over the plaza. And there are these interaction points, and visitors can trigger different bursts of color that are animated within the sculpture. And there is an Easter egg. If they all synchronize their activity, then there's this big like supernova that happens within the sculpture. Similarly, this shifts palettes over the days and the weeks, having a more muted palette in the winter and a more vibrant palette in the summer, and activating this plaza for everyone who comes through. So I think obviously there's some overlap between these strategies, but they have allowed for creating these much more site-specific and unique digital experiences. So thank you.
Right. Thank you very much, Mari. Okay. So yeah, three of you show us a really amazing works, and then I think like so each of them, okay, all of you has a many aspects, like dealing with many aspects of human aspect to technology aspect to the kind of realization aspect. But I think like in my observation, I think the Volkan's work shows more into like showing the technology challenges and then solutions. And then Brian shows more like integration of technology, and then Mary's work shows more like experiential human side in a way. Although actually one thing I'm just curious and sorry if it's not like something you can talk work. I want to ask you that like in your professional work in the product design area, is there any difference in terms of the design flow or like a focus point of attention between like your computer design work to the product design work? Is there any kind of unique aspect in the field? In abstract sense, to the range you can talk.
Yeah, I mean, it's a matter of scale, I would say, right? Obviously, there's a difference there, but it comes down to many things. I mean, I'm a trained architect, so I used to design buildings. Now I also work, in the product space. Everything is smaller. but you still have to think about the same elements in the same systems. It's still about material, it's still about the construction, it's still about the connectivity, the details, how things come together. And it's also working with partners. I mean, we also have color material designer, we have engineers, we have developers, we have factories. So it's very similar in nature. It's just with architecture you do one, and with product you do smaller but many, right? So there's different kind of challenges that are involved with it. And also, the storytelling is very different. Like you have a whole marketing team when it comes to products. They take care of all the world that you're not really that familiar with. And especially if you're a global company, if you're in the architecture space, you have maybe one client for one building. You deliver the building and then you walk away. And it's different with products because they work seasonally, and there's this continuous need for new product and to elevate products. So it's different landscapes, but there's a lot of overlap. And I think the benefit of an architect is that we've trained in a way that we can handle those ecosystems very well. And that's why you see a lot of architects also be able to work in other industries, like at Samsung or at IBM, many other places. So I think that's the benefit of architects, that we have a kind of a system thinking upbringing or kind of education, and that helps us connect the dots better.
Right. Thank you. So actually, yeah. So the one of the key keyword Volkan mentioned in the beginning, like the system will be one thing like which really governs, not really govern, like one framework we can see. In a way, also the storytelling is another aspect, and although that was a kind of marketing aspect, but it's similar to the narrative, like a work narrative you bring in that project. And then, so one thing that I want to ask you all is that, so like so like for example, so the married work experience side, of course, you assume the audience and what kind of experience you provide, what kind of perception you provide. That's one thing, human aspect. And then in Brian's case, also yeah, your work with all kind of many kind of intelligent technology. However, you also really care about how people, the way people can interact. Also, what kind of perception or sensation they get. Especially like even the aspect of like a tactilization of the music, like music cassette project. There's also nostalgic aspect as well as aesthetics, and also the kind of feeling as well. So those kinds of things is something not not like directly dealt within computational design in like early age of like 2000, 2010. It wasn't kind of part of it. But if you look back, actually, if you just simply look at the profession of architecture design, it's actually all of the things, all human related things or manufacturing related things is actually part of the architecture profession. So in a way, I think like also I'm just trying to see the framework of discussion. In a computational design, so now technology is getting more sophisticated, and then we are dealing with more problem, the more factor, and then that was already that has been there by the architecture profession. However, that wasn't systematic. That wasn't like organized that wasn't computational at all. However, we might be getting the point where we could like technologically approach to this really human or perception or experiential or very abstract part through technology, or at least like as a computer designer we can organize or set up a rule how to deal with this very abstract something difficult to the factor which is difficult to deal with. It could be systematized or it could be part of the system, as Volkan mentioned. So that I think that kind of the way I see that where you guys might be working in a way, in a certain way, or either there might be possibility to like expand further in this area to really like to produce much better design work integrating many things. So kind of that's how I see the framework of the discussion, and then I want to ask opinion of your participant. Anybody has any opinion on that? So
I was just thinking as you were saying that
Mhm.
that Yeah, I mean, I guess architecture historically, like the output of the process is a complex system, and it's a system of relationships and between like objects and systems and subsystems, and also the place where people interact and have experiences and all that. So it's always been about systems design. And then with the introduction of technology, you have, new ways of thinking about and conceiving of and organizing those systems and designing for those systems. And then when the technology has kind of advanced and made itself so ubiquitous, in all of our lives, now we actually have relationships with technology. So there's like a new set of relationships to design for. And so I think, an architecture way of thinking is I think applicable obviously to all of those. And I guess the thing that you said that I resonated most with was, or the thought that I had that came from reaction to what you said was the like thinking of the relationship with technology as a thing that's actually being designed for as a system, as an experiential system, which is also something that architecture always was.
What do you think, Volkan? Especially like when you mentioned about like in the bridge project. Actually, not even the 3D printer sculpture project. You mentioned about the inspiration from the book, and then color, and then also I think form was informed by that. But I think that could be. I think inside you as designer, there's a certain rule or system how you connect those things. And even the bridge project like bringing the connectivity between two neighbor and then chair and maybe the place for the interaction for people. That kind of, I mean, of course, architects deal with this kind of way of thinking, but in your mind, I think there's a more systematized way to deal with this thing. So, what do you think about like also possibility of like, going further and further in a more systematic, more maybe complex, more not need automatized, but like even in concept level, like expanding our imagination concept with technology, there's something you think possible or something thinks a promising thing to do.
Yeah, I mean, it's interesting, and I want to connect a little bit to Mary's work as well that she's shown, because I think when we talk about systems, and Brian is right, systems have been around for a long time. If you think about a designer or an architect conceiving an idea, it's about design thinking. There are several steps that go into the design thinking. You don't have to necessarily go one after the other. You can iterate between those. But there is a formula how to kind of start a project, do the process of the project, and deliver the project. But I'm very intrigued by these new technologies that might actually help us break that paradigm a little bit. So when I see some of Mari's work with those screens and how the interaction works, I feel like that could really start to replace some of those paradigms that we have when it comes to design thinking, which is in a way very linear sometimes, and there's feedback loops, etc. But I feel like there's something where that process really becomes the design, right? So that's why I'm really always intrigued when it comes to UX work or interactive work that Marie showed, because that's a world that I have no experience in, and I feel like there's so much potential because you're able to capture information and translate information and give information back to an audience in real time. And I feel like that has a lot of potential to kind of really, let's say, change the playbook of how we design and how we conceive ideas.
I think that's part of the hope in inserting computation, live computation, real-time computation into a space, is that architecture is often there to facilitate something, some kind of program, some sort of experience, business success or civic success, and it's amazing to be able to insert these more dynamic tools to address that more directly or to engage people maybe with more immediacy.
Yeah. Yeah, I think that like the experience or in a way so the narrative aspect is somehow directly deal with the data visualization in a way, like the way you show data or the process you when you take the big data and how you, do the calculation to change that to the visualization, that is actually part of the like a narrative manipulation in a way. So that part is interesting in a way. But however, actually, so another thing I want to expand further is that so now we think that this kind of a human technology, a human and thing interaction area, which is, of course, architecture is a framework of this. However, beyond that is there's another like a stakeholder, like for example, the marriage corporate work, there's a visualization, there's a client, and then I mean there's an audience and then client, and also the manufacturer, and so all of those kind of related party or involved party existing. So meaning that so this systematization can go even further to that area, meaning like a full system of like a design to manufacturing to experience to that. Is that something like which could be integrated? Actually, I'm just yeah, throwing ball and just making the topic bigger and bigger. But if you think of any like a possibility in area like because when I see Brian's work, I see he's trying to connect that dot which wasn't connected before. So if computational design has this capability of like connecting components which wasn't there in design process before through technology, then in that case, yeah, can we go further and further? And what is a possible thing we could connect? Yeah, that's actually the question. So, do you guys have any opinion, idea? Those? Or even like politics, environment, and those anything.
I have some thoughts that are heavily influenced by my current like addiction to using Claude Code to vibe code projects. And now I'm like using Claude Code to vibe code systems of more efficiently interacting with Claude Code. So, like I just posted on Instagram a thing to use face tracking, eye tracking, and like wink gestures and voice dictation to like look at a screen of a grid of Claude Code terminals, and you look at the one that is waiting for your input, you speak to it, and it keeps on going. And so, I don't know. I know that some of my kind of obsession and interest, it feels a little bit dark, Black Mirror, post-apocalyptic or whatever, but the reason that I'm so obsessed with it is that it's just shrinking the gap between like the conception of an idea and making it real. And there's something that designers or makers, I think, all kind of are drawn to in that process. And so to when we have kind of a limited amount of time to express the things that are in our minds, and technology allows you to get more of that out. I think that's kind of what is so enticing to I think that's maybe kind of underlies a lot of what's enticing to people about technology, in addition to kind of like allowing us to maybe recognize disparate objects that haven't been previously connected, and to see an intermediate step that it can be connected through this other way of thinking or this other technology or this missing piece. So that's the thing that I like most about that is the process of designing with computation.
I almost certainly got into computational design and 3D printing, which I didn't talk about that much today, because of this Star Trek episode I saw as a child, in which someone, like has this image of a dolphin in their mind and just like, mentally, uses technology to carve it out of wood. And yeah, I think that having that sort of immediate gratification it's incredible. It's like such a privilege as an artist and as a designer. But I also wonder, like, it reduces the amount of intention in what we're making. And when I see Volkan's work, I just think about how much commitment goes into that, the amount of thought and effort, and it makes the work, necessarily more thoughtful, I think, and more intentional. And so there's value to that as well.
Yeah. Okay. So yeah, those are kind of discussion going further, and but one thing, yeah, like Brian Mary mentioned was something about like speed of technology, or like a level of interaction, or like like speed of connecting different thing, and then each creates bit maybe different type of experience as well. Okay, so if you like have like a free instruction system in front of you, and then like or even for making something, for example, if you have like a full robotic system for construction, and if you just think of something and something is built in front of you, that become an interactive architecture in a way. You become like an audience, or any public people become like an architect as well. So also like a maker and then consumer kind of getting closer and closer. But that's one aspect. And then, but I think like I think like I think that the kind of topic is kind of getting kind of all over in a way. But so I think, but as a framework, I see from the observation I see today is that like it's not like there's a more area we can explore. It's more like there's a immense area, immense kind of world that we can go further and further. This is just seems to be just the beginning. I'm not sure if that term computational design stays or not, but this way of design seems to be the like still like a still in a way very traditional in architecture. I mean, just trying to not about connecting dots, but really trying to think about many factors and then try to formulate in a way. And then with computation technology or even computer programming or just computer, we just accelerate that and then easier to integrate. And even AI may be accelerating many more things. And so meaning that I don't think this is just like a I mentioned the boundary computer design in the beginning, but it was more like it's open-ended in a way. So it just go over everywhere. And I think that that's the way I see now from this conversation. So that's kind of I'm trying to get it to the conclusion of the panel discussion. And also maybe if there is any kind of final thought from panelists, you can uh, talk. And do you guys have any kind of last comments on the panel?
Yeah, I mean, I can maybe just say that you know, when you look at the power of computational design or the power of computational tools, and if you look at these companies that are introducing those tools now, either established companies like Samsung or Nike and so on, they bring in these computational designers, computational capabilities, and they basically use digital transformation, right, to do this. And if you look at digital transformation, you know, it's about business transformation, domain transformation, process transformation, cultural, organizational transformation. And I would say for a long time, these transformations were only limited with the computer design tools to process transformation. We introduced these capabilities to maybe speed up things, open up maybe opportunities that you didn't have before, because these tools now can do that. Obviously, cultural organization transformation, where you introduce new teams that never existed before that into these organizations, and they start to really reshape the way people work and are connected. But now with these new tools, and especially with, you know, with some of the tools that Brian is showing, it's really like the domain changes and the business changes, right? So just think about Apple, where they're doing products like a laptop or you know, an iPhone, and then they go to platforms where it really is a totally different a business, right? And these AI tools now can really start opening up opportunities for many other companies to go that route, to invest into those opportunities. Or if you think about Netflix used to be where you know, and I used to be one of those customers that gets a CD in the mail or DVD in the mail, and you put it into your laptop, you watch a movie, you send it back, until the technology online was so sophisticated that you can actually stream videos now, right? So the domain changed. So I feel like there's just so much opportunity now, and it's good to also think about it from a bigger point of view, how these tools can impact you know, our day to day, but also how they can impact the companies around us and how they will switch and change in their objectives.
Yeah, I think like so opportunity is a really like important word that you just used. Like when I think of, I don't know, if I zoom out, I try to kind of summarize all of my thoughts around this whole conversation. It's like, okay, if architects or designers are good at looking for opportunities and defining relevant constraints for a project, whether it's, you know, the client, whatever, and then iterating through this process of design and optimizing, let's just use that word, to find a solution to that satisfies all of the relevant constraints. I think that like the role of the opportunity explorer is kind of an important part here. Like when Mary's talking about like this particular three-dimensional video box creates brand new opportunities that maybe designers haven't had to think about before. So it creates this new opportunity to invent, you know, methods of design and service of design. And similarly, like with Volkan's projects, like thinking about all of the relevant constraints for the bridge project or the robotic fabrication stuff, and understanding the pros and cons and limitations of those processes and what compromises need to be made. I think technology, in my view, like I definitely I always go after the instant gratification, and it's something that I'm like, have to kind of keep in check. But it's also something that allows for so much more iteration within a kind of problem space. So it can allow you to kind of dig maybe deeper than you would have before by being exposed to like so many different opportunities that you might not have been able to conceive of on your own, which I think is a interesting aspect of this as well.
Ultimately, computational design is designing systems to solve a problem, and I think that's what drew me to it in terms of kind of classic computational design as we think of it in architecture, like being able to generate like thousands of forms and choose the ones that you want, or iterate around that. It's just a powerful way of approaching design across a range of different problems. And I look forward to seeing more of your work. Really, really great meeting all of you.
All right.
Thank you as well.
Great. Right. Thank you very much, all the panelists. And then I think that because of limitation of time, we need to conclude this panel discussion. And yeah, thank you again to the viewer, to the panelists, and for this discussion. And so now we conclude this panel discussion. And I have, thank you very much, and goodbye.